Hello, doctor.
Yes.
There was interruption. It got cancelled. Yeah. Yeah.
Yes,
Yeah.
it has
Now
been
I got it.
cancelled. Okay, Shashi Kumar, Pillai asked the question. After that, I'm also having some question related to your objective, second and third one. Okay, please continue your answers anyway.
Yes, doctor.
You can share your screen.
Are you able to see my screen?
Yeah, we are able to see.
Yes, Doctor. Mr. Pillai's question was regarding lithium ore extraction. Lithium ores are mainly present in Chile, China, and another country which I don't have full information right now. I am still going in details about those information. And from the literature, what I understand is even lithium ore extraction also produces a lot of heavy metals and causing environmental pollution. That is also one of the main concern of recycling the lithium. From the literature, they say around 60% of the lithium ought to be recycled back. If not, we cannot sustain with the available lithium ores. So I have to go in detail about those particular information. Definitely, I am working on it. I will maybe on another presentation I can give in more details. Even it is more costly to extract lithium from the natural ores available now. And some literature say even recycle is cheaper than taking from natural resources. So more research is going on recycling of lithium ions.
So it is cost involved, not it is not a toxic one. So based on the scarce metal, the main drive for recycling lithium is because of the cost of extraction, right?
Yes, Mr. Pillai, yes. As per literature, that is the information what I have said, I have seen. And in detail, the information about pollution is not given. I have to further go in details on that. I have noted down. Next time, I will try to give the information on that. And in the previous presentation, we've been asking about the effect of lithium in comparison with lead. Definitely, lead is better than lithium is better than lead. Lead is more poisonous, more heavy than lithium. So, better alternative for lead is lithium.
Okay. Yes, Shashi.
Yes, Doctor.
Dr. Shashi, can I have two
Yes,
questions,
please.
please?
Yes, please.
Good morning, fellow doctors. Dr. Shashi Kumar, with regards to your presentations, I'm just only curious regarding, like in UAE, due to the proliferations of the electric vehicle has been allowed by the government to operate or to sell in UAE. Is there any documents or coming from the UAE regulatory bodies or authorities have been proposed or required to these companies on how they dispose, recycle, recharge, or by any means pertaining to their batteries has been required by the government?
So based on literature, government has not given such a document, but now in UAE at Sharjah, a new recycling facility, lithium-ion battery recycling facility has been proposed, and a lot of initiative has been taken. All throughout UAE, all lithium-ion batteries will be collected and recycled in that particular facility. BEAH, that particular concern is going to propose a recycling facility at Sharjah. So, as you asked, the document I was not able to see, but the government has decided to have a lithium-ion battery recycle facility, especially for this type of batteries.
I see. Because to my part, because if I'm gonna be the end user of a certain vehicle or an electric vehicle, I would be trying to one of my concerns will be pertaining to the warranty of the battery. At the same time, what would be the the company or the corporate uh, strategy or pertaining on how they will gonna have to be replace, recycle the
Um,
battery as their part of their products and services to the consumers.
yes. As per available information, this lithium-ion batteries life cycle is 10 years. At the end of 10th year, the battery capability will be reduced by 80%. So what they say is if battery capability comes to 80%, then you have to change the batteries. So after 10 years, definitely it happens. The end user has to change the battery and he has to recycle it. He has to give the battery to the recycle companies where they can do the recycling processes.
I see.
Um,
So what would be now the part of the company that I both like, the BYD, the Tesla, just in case after their warranty? So what would be their participations on discharging or disposing these batteries? Because if I'm going to be the end user, I don't have the means and capacity to properly discharge or dispose these batteries if I'm going to be one of the end user of their car or their products for these things per se. Just only a curiosity kind of questions, because I'm sure that the corporate or the institutions, I'm sure they have this kind of way of, or I think one way or the other, this is gonna be part of the marketing strategy to lessen the burden on the end consumers or the customers pertaining and availing their products, that in the future this will gonna be a probably a next problem or dilemma as part of their services or products they're selling to the communities. Dr. Sashi.
yes, Dr. Ami, your point is very valuable question. So I have to get in details for that one. I saw one of I can share one information which we had um, so that you can get some idea about that. If you permit me, 2 minutes of your time.
Go ahead, Dr. Sashi.
Are you able to see my screen? Are
Yes,
you able to
Dr.
see my
Sashi.
screen? Yeah, you
Yes,
can
yes,
see
Dr.
this
Sashi.
particular material. BEAH Recycling, UAE Ministry of Energy and Infrastructure and American University of Sharjah to launch UAE's first EV battery recycling facility. In year 2020, this was unveiled actually. And in a landmark, these organizations are exploring the development of state-of-the-art recycling facility for the end-of-life batteries from electric vehicles, supporting landfill waste diversion and sustainable growth of the EV market on 19th January 2023. So there is something going on government level, and definitely your questions will be answered as a document, and maybe once this is established, BAH Group's waste processing and material recovery business is established, no? And maybe some regulations will be there to dispose of the EV batteries. And Mr. Ruben also last time he was asking, but from year 2017, this EV battery started in use. So 10 years means 2027. From 2027, you are going to get all E battery waste. Somehow we have to manage such a big chunk of materials. Yeah, in my presentation in the coming slides, I have given some data with respect to Dubai's LAB waste. I can also show that one. So your points, definitely there should be some regulations going to come in future, so that all end user definitely have to uh, dispose of these LAB batteries very safely, and it has to be recycled back. It has to be given to recycle facility.
So see, still, I'm sorry. Still, the lead acid is more toxic than lithium, isn't it?
Yes,
Le-
yes.
Lead acid batteries are more toxic than lithium. How that lead acid practical at present, the batteries are being managed after their end of life. So still that question, sorry, I'm not able to understand. So if that is not a problem, then how come the lithium will be a problem in future? Why we are considering that?
Lead acid battery is also a problem. The lead acid batteries are also recycled back as a lead acid battery itself. But lead acid battery cannot be used for running the vehicle.
No, I understand that. So now, for example, on the road at present, all over the world, millions and billions of vehicles are there. Each and every vehicle is using a battery, right?
Yes.
For to start the car. These batteries has some end of life. After that, what they are doing it? How even after recycling, it has an end of life. Everything is will have an end of the life. No, we cannot go on recycling numerous times. There will be end of life for certain after usage. So how it is being managed? Lead is more toxic than lithium. That's what you presented, right?
Yes. Yes.
So how it is being managed? If it is managed well, what will be the problem for lithium? Lithium is very scarce material because of the cost of production. We have to recycle, not considering the toxicity, right? So the environmental concern will be less when compared to lead oxide or the lithium oxide battery, right? So only the cost of extraction will be high. That's the reason we are forcing for recycling. My understanding is correct?
Yes, your understanding is correct.
Okay.
Lead acid battery presently, if you want, I can show one video how they are recycling back the lead acid batteries. All lead acid batteries are collected and it is being recycled now.
Okay. So
If you
first
allow me, yeah.
no, it's okay. The first cycle they will recycle it. After first usage, they will recycle it. After 10 times of recycling, it has some life cycle, right? It has to be thrown away. That cannot be recycled anymore, right? Or it 100% it can be recycled numerous times of usage also. I want to understand just.
Yeah, 1 minute. The number of times of recycle information, I have to further go on it. In the one of the documentary film that regarding this recycle of lead acid, they are producing a new lead acid battery. If you give me time, I will now play that particular video. Maybe further upon we can discuss also. I'll just go through the video. Sorry, team, I'll go to the end of this particular one. I just played one YouTube video.
Mhm.
I'm not sure whether you're able to see it. I will stop sharing and again share it back. Are you able to hear hear sound on that? Are you able to hear sound of this particular video?
So
Your
far,
vehicle
no.
makes
No,
this
no,
sound.
Now okay.
Shows this frequency. Now,
Hello?
now we can hear.
Yeah.
99% of all lead batteries are recycled, making them the most recycled consumer good in the United States. Nearly all vehicles on the road in the United States are powered by a lead battery, and many electric vehicles contain lead batteries as well. At the end of their lives, retailers package the spent batteries they receive from customers like you and ship them to an EPA-regulated facility called a smelter. Here, the first step in the battery recycling process occurs. Once batteries arrive at the smelter, they are taken to the receiving area to be processed. The batteries are removed from pallets
So these are lead batteries which receive to the terminal.
and are inspected to ensure only lead batteries are entering the recycling system. This safety inspection is important to identify any lithium-ion batteries that may have been
So we can see here they're segregating lithium-ion battery, which is coming by mistake also. Only lead-acid batteries being used for recycle.
packaged with lead batteries. Lithium-ion batteries pose a significant risk as they are highly flammable and can create dangerous conditions during the lead battery recycling process. The batteries are fed into an enclosed machine with rotating hammers where they are broken apart through an automated process and the acid is drained and collected. The broken bits of lead and plastic tumble into a separation tank filled with water where the lead components sink and the lighter plastic pieces float to the surface. Using these differences in density, the plastic is separated from the lead. Each material then goes through its own individual recycling process. Let's take a look at how each of these components of the spent batteries are recycled and reused. Reclaimed lead will be smelted, refined, and reused in new batteries. This amazing process recycles virtually all the lead and can be repeated indefinitely. During the smelting process, scrap lead materials enter a furnace to be reclaimed. After smelting, the lead is then further refined, and additional elements are added to create alloys for use in the manufacturing of new batteries. The newly alloyed lead now gets poured into bar-shaped molds called ingots. The bars are stacked and taken to the manufacturing plant to be reused to make active material and grids for new lead batteries. Reclaimed plastic pieces from the battery crusher are cleaned and melted in order to be used in the molding of new battery cases. The plastic, or polypropylene, is filtered and extruded into pellets, ready for the injection molding process. And finally, reclaimed acid can be purified for use in new energy storage devices. However, most reclaimed acid is chemically treated and lives on in the form of sodium sulfate. After the acid is neutralized, the sodium sulfate crystals are separated from the liquid through a distillation process. The sodium sulfate can be isolated and dried through a multi-stage process. The purified sodium sulfate can be sold for use in common household goods such as powdered laundry detergents or by the glass industry in their refining process. The remained neutralized liquid meets regulatory standards and can be safely discharged or reused in the battery manufacturing process. Now let's see how these three highly recyclable components come together to create a lead battery. Once they arrive at the plastics facility, the recycled plastic pellets are blown into an injection molding machine. The injection molder melts the pellets and uses pressure to push the liquid plastic into a metal mold. Each mold is different, depending on the size and shape of the battery it will become. New cases are cooled, quality checked, stacked for delivery to the battery assembly plant. Any cases that do not meet the quality standards are recycled, creating virtually zero waste. After arriving from the smelter, the recycled lead ingots are remelted and the liquid lead is made into battery grids. Grids are an essential part of the battery's power delivery system. The grids are then wrapped around the tube, ready for the application of the active material that stores the power. Under tight computer controls, lead oxide is mixed with water and other materials to create a paste. The paste forms an active material that enables the battery to store its energy. The paste is then applied to the grids to deplete the battery plates. Positive and negative plates with protective separators are grouped together into cells and inserted into recycled plastic cases, and the cells are connected together to allow the current to flow through the battery. Covers are added to complete the assembly process. The batteries are then filled with fuel or reclaimed acid, sent to a holding area to be electronically charged anywhere from 30 to 60 hours. At this point, batteries are considered fully formed and are thoroughly tested and prepared for shipment and ready to go to retailers and consumers across the country, thus starting the cycle of use and reuse all over again. It's clear just how sustainable the lead battery in your vehicle really is. Through an ingenious process of recycling and reclamation, lead batteries have become one of the most recycled products on the planet. Lead batteries used to power cars and store energy in so many applications are one of the best examples in the world of a proven environmentally conscious technology. So the next time you see this light, think about the role you play in smart energy storage decisions. To learn more about lead batteries and their recycling process, visit batterycouncil.org.
First time seeing how a battery is made of.
Yes, doctor. So from this one, we understand that lead acid batteries are purely recycled, and we get a good and fresh batteries. So, but I could not answer Mr. Pillai questions after 10 times or 20 times what will be happen. But from this one, I understand where we get a new battery, lead battery. So again, the recycle continues.
Fine. Thank you.
Got it.
So I'll go back to the old presentation. So I was talking about solid batteries, solid state batteries. So now we'll be talking about lithium-ion battery recycling process. How to recycle the lithium-ion batteries. There are many methods going on still. Research and developments are going on. It is unclear which recycle method have the least impact on the environment. Lithium-ion batteries cannot be recycled in conventional ways and require taking them to trusted recycle centers, which Mr. Ami was asking, where it will be treated in the right way. That is very important. EVs depends mainly on lithium batteries, and the developments of this type of batteries will define the future of sustainable mobility scenarios. In this lithium ion recycling, one of the major contributors is supply of copper and aluminum for anodes and the cables. The industries of EVs represent one of the most ever-growing sectors, which reflect to the increase of the need of lithium-ion batteries. Thereby, the situation will lead to serious disposal problems and negative impacts on environment and energy conservation. Hence, the spent lithium-ion batteries starts to receive attention in recent years.
We're not able
There
to
are
hear.
three. Yes, yes, doctor. I'm
Yeah,
just
yes,
seeing these papers.
Okay.
One. There are three main recycling methods as of now. Pyrometallurgical, which is smelting. The batteries are dismantled and later on smelt with a slag forming agent like limestones, sand, and slag. During this process, the electrolyte and plastics are burnt, and remaining material is composed by alloy of copper, cobalt, nickel, and iron. This process is economical for batteries with cathode materials containing cobalt and nickel, but not for newer designs with manganese or LFP cathodes. There is another method called hydrometallurgy, which is a leaching method. In order to start the hydrometallurgical process, cells of batteries have to be dismantled or shredded. The hydrometallurgical process basically dissolves the cathode into its constituent ions by using strong acid to convert the cathodes to liquid solution. Using strong acid will increase the complication and cost of process. I'll give the various energy involved in the coming slides. There is another method called direct method. Basically, it consists on extracting different materials of the battery and reintroduce them into supply chain with little or no additional processing. Main techniques to separate materials are based on electronic conductivity, density, and other properties. This process has the advantage almost all the battery components are recovered. One of the limitations of the process is the quality of extracted materials. The purity is less. Depending on the application and specifications, the usage of these materials could reduce the performance of the future manufactured lithium-ion batteries. And there are comparison of these three processes there. The comparison is based on the energy required for producing new lithium cobalt oxide. That is the basis they have considered. Various recycling methods is taken place here. Number of recycling they have considered 150 times for all the constituents. The energy required is in megajoules per kg. You can see the three comparisons for pyrometallurgical, hydrometallurgy, and direct. If you see in this row, pyrometallurgical, the energy required is comparatively higher than other types. Pyrometallurgy, if you see for lithium cobalt oxide, 110 megajoules per kg of energy is required. For copper, 100 megajoules per kg is required. This is not applicable. Whereas hydrometallurgy, the energy required is only 87 megajoules per kg for lithium cobalt oxide. For copper, it is 80, aluminum 67, and anode type is 46 is there. Whereas direct method, the energy required is slightly higher than hydrometallurgy. Based on the energy, they recommend to go for hydrometallurgy type of processing for recycling the lithium-ion based ions, the lithium-ion based batteries. So this is one of the outcome of the study with as of now present technologies. So now I go back to the statistics of this type of lithium-ion batteries. There was a case study in Dubai. The government of Dubai expected number of EVs by 2030. These are the numbers available here. On average, they found 8.2% increase is there.
Pillai, this is the case study that you have collected on the basis of your study, right?
Yes.
Okay.
Continue, please.
So in Dubai, The expected number of EVs by 2030 is found to be like this. 2014 it was 1.4 million vehicles, whereas in 2030 it is 4.94 million vehicles. And based on battery lifespan, which Mr. Amy was asking, when lithium battery degradation reaches about 80%, this level considered as the end of EV battery life. The average lifespan for the lithium batteries that used for EVs is usually as a calendar life of 10 years. The expected annual waste from lithium-ion batteries tons per year these are the numbers. By 2026, 86,378 tons is expected, and these are the numbers available. It's a huge quantity which government has to take some action on that. This is the number given for Dubai. Going forward, I want to check for total UAE. That will be one of my work for this research. We'll try to collect the data also. So with respect to recycling methodology, already we spoken about it. So in this study, they recommend to go for the hydrometallurgical type of recycling process. This is what as of now available in all the literature. Apart from this study, in other literature also they recommend this type of what to say recycling methods. As a conclusion, it has also been told the same methodology. According to, I'll just go through the conclusion in this particular paper which I've seen. According to calculation, there will be a large number of lithium batteries that will need to be recycled. Thus, UAE will be going to face various challenges regarding waste management, such as developing recycling infrastructure in the near future. So now they take an action in Sharjah. They are going to open a big facility for lithium-ion batteries recycling. Because of different metals and plastics in the lithium-ion batteries, there will be an economical value for the waste stream of these batteries. It is going to definitely give a new business to others. Various environmental issues associated with electric vehicle batteries, including landfill lithium batteries, represent environmental risks because of the leak of the organic electrolytes. So, as outcome and recommendations in this particular paper, they say recycling infrastructure to be available to the public to recycle lithium-ion batteries, provide a legislative framework that regulate random recycling lithium-ion batteries, which Mr. Ami was asking, reuse battery cells and packs with remaining life in other applications such as stationary energy storage system, safe disposal paths for materials don't have any additional values or secondary life, build recycling infrastructure capable to deal and recycle huge amount of materials for very battery chemistry composition. Also, the researcher has to overcome obstacles and limitations faced while the research was conducted. It is recommended to implement the hydrometallurgy method according to the comparison between different processes. So this is the recommendation given in that particular case study. And with this, I stop my presentation. I had another video. If you permit me, I can run this video also, which gives an idea about how the battery basics in being explained for EVs actually. Shall I play this video?
Yeah, sure. What will be your research question? So the research paper already you reviewed. It is recommended to go for hydrometallurgy, right, for the recycling of lithium-ion battery.
Yes,
so these are the recommendations. Reusing the battery cells, and still it is there are more additional value. Then you have to go for recycling and proper way for recycling infrastructure. This is the recommendation from the previous paper. So what will be your research question?
My research question will be actually this particular case study data is only available with respect to Dubai only. I want to further check for total UAE. That will be one of the work for me. And next one is hydrometallurgy method. Further any improvement I have to check. and want to give some recommendation on the same methodology, if anything is available, because almost all the I have surveyed some 10 to 15 papers. In all papers, the details of hydrometallurgy I could not get it. Further, I have to go in detail for that particular method and see if any developments can be proposed, so that this is one of the thing what I'm having in my mind. I'm open if any points is there, I can further look into it actually.
Yes, Shashi Kumar,
Yes,
what we
doctor.
can do that, if you can share your slide in the group,
Yes, doctor.
in PhD group, and the link will be uploaded, yeah? YouTube will be there, right? The
Yes,
PPT
doctor.
itself. We will be watching it. And apart from that, Pillai and Shashi Kumar, you have done your 2 presentation. And now what you can do for final confirmation, I can also work on your research proposal. That's why. This is some of the lithium and the word that you are using, the scientific words, that is not much familiar to me, but I can just relate to the business administration point of view. I can also relate to the thesis point of view, the PhD point of view much. So what Pillai is suggesting here, you can incorporate with your work. That is really important. And once you send me, right now you take your time. We have almost, yeah, this coming week will be off. Then after that, Army's presentation is there. Before that, before you are coming on the next coming presentation, you both can prepare your research proposal, and we can almost finalize your thesis topic. Now, little ambiguity is there in the Shashi Kumar EV battery. Topic is fine, EV batteries and all, but what we need to finalize in that, our research questions and objective, we need to be more crystal clear. That's only the aspect is pending. Other part is fine. We'll be working on it. We need time for making our research proposal finally be polished. So what you can, both of you can do that, be ready with your research proposal. I can work on that. Yeah, I can work on that. And I'm just in discussion with our team. So once your research proposal is ready, we wanted to send to GAU, the research team. They'll be finalizing and they'll be confirming it in order to proceed with your topic. Once we got the confirmation from them, we can proceed with the same topic. Yeah, we don't need to make any changes. They'll be also amending some changes if it is required. Hope it is clear, Pillai. Yeah, Pillai is clear, right? Okay.
Doctor, my research topic, is it okay? Because I have changed my
EV,
research topic.
yeah, EV battery, sustainable growth in the EV battery, right? Your topic is related to that.
Yes, doctor. Study on sustainable growth of EV industry. I changed my
Study on
topic.
sustainable growth in EV industry. That is okay. Related to business administration, EV industry is fine.
Yes,
And sustainable growth is fine. Today, your presentation is more into the theoretical perspective, like the types of battery and many other things that you discussed. Is a part of the presentation, I understand. I want to scrutinize your research questions and research objectives once again in order to support your topic. Your topic is fine. I don't have any disagreement. You can go ahead with your topic because you're talking about the sustainable growth in EV industry. Particularly, you are also talking about the UAE. And since UAE is giving more importance for the sustainable growth, yeah, sustainability, sustainable growth, many things. So you can have a more scope on your topic. There is no problem for continuing your topic. But my concern is what all should be your major hypothesis and objectives for your study that we need to reframe once again.
Okay. Okay, doctor.
Yeah. So I believe you may be having some informal discussion with Pillai and Bala on your topics, yeah? Sometime whenever you meet each other. So
Yes,
continue. It will be really good. I understand. And yes, you try to incorporate what all the question we have asked the previous time. Somewhat you just made an attempt to incorporate it.
Yes,
And
doctor.
you do one thing. Please share your slides into the PhD group, and you can also do one thing. Yes, both of you, please prepare your research proposal. Meanwhile, I don't know whether you are going through the tight schedule or not, but if you get some time, what all you have written in your PPT slides that you are taking from there, you are just making the changes as per our discussion. Other researchers are contributed in your discussion, you can make it done. And just make a research proposal. What all the important parameters comes under the research proposal that we have discussed previously as well. And you just follow that and just do and send to me. You have a 15
Okay.
days time. Yeah, that's all.
Okay,
Almost
doctor.
okay.
Okay, doctor. And moreover, the discussion points to the maximum extent I tried. Still more points I am working on it actually. So, for example,
Shashima, it will take a lot of time. Because the topic is very huge. The topic is EV industry is not a simple topic, yeah. Because number of changes are asking, number of changes are being amended every time. So yes, some of the question you didn't answer it because it will take time. No worries on it.
Right. Mr. Pillai's questions also I'm having in mind. Still I'm working on it. With the available information today I presented. Definitely, furthermore I have to go in detail actually.
Yes, I understand Pillai question is very important. I will tell you, Shashikumar, the reason. Since Pillai comes from a background of having a knowledge in this area, so it will be very good to incorporate with your topic. It's really good. I'm also looking into, because as a person from management commerce background, my expertise will be in that area. I can support you for all these areas: EV industry, sustainability, growth, entrepreneurship, everything I can relate it to that. So when we are going for framing the research question, we'll be more concerned to industry perspective rather than a scientific perspective. Perfect. Thank you. Thank you so much. I know that today almost morning, the 10 minutes or something, you got some inconvenience. I was in a meeting related to passport and etc. But done with that anyway. Thank you so much for your patience. Thank you for joining. Pillai, Ami, I really appreciate Shashikumar for joining for every sessions. And Bala is in his mother's rituals and all. He informed me today morning, and let it be done very well. And other researchers, they also inform me their absence. And you people are little ahead compared to others. So now I believe your research proposal, once ready, we can go ahead with your work. Thank you. Thank you so much. Thank you. Ami, be ready for the next time, the presentation. Okay, Ami.
Yes, doctor. No problem.
Thank you, Mr. Pillai.
Yes.
Thank you, Ami.
Thank you so much.
Thank you.
Have a good day, everyone.
Thank
Bye-bye.
you. Good.